Hello dear students, greeting of the day. I Hemant Sharma welcome you in my channel Vasu Electro Tutorial class. So in our today class, we now going to perform the experiment of DC motor speed control using potentiometer. So actually I performed this experiment by using hardware on the hardware. So if you want to grab the more knowledge that how to perform this experiment on the hardware, so you may visit my YouTube channel, and I also provide the link of that experiment in the description box. Okay, so you may check the experiment in my description box. So now and today's in our today's lecture, we going to perform the experiment on the Tinkercad. Okay, so design of speed control of DC motor using potentiometer. So before starting this topic, we must know about the circuit diagram of this experiment. So I want to show you the circuit diagram for the same experiment. So here you see that this is the circuit diagram for performing this experiment on the Tinkercad. So in order to perform this experiment, we use a Arduino and we use a motor driver circuit. So here, this is our Arduino, as we very well know about what is Arduino, and this is our motor driver circuit, and the IC name is L293D. So before going to discuss, so we first know about the driver circuit, motor driver circuit. So motor driver circuit is actually a 16-pin IC. So the first pin of this IC, so first of all, we discuss about the pin description of the L293D IC. So as I already telling you that it is a 16-pin IC. So the first pin of this IC is enable 1, 2. Second pin is input 1. Third pin is output 1. Fourth pin and fifth pin is ground. Sixth pin is output second. Seventh pin is input second, and eighth pin is VCC second. So in order to enable the left portion of this IC, we give supply to the first number pin, that is enable. Okay, so the second number pin of this IC is used to give input. The second number pin of this IC is connected to the digital input output port of the Arduino. So as we very well know that in the Arduino we have a 0 to 13 number pin for the digital input output. So we connect the second number pin of this IC to the 0 to 30 number pin, that is digital input output pin of the Arduino. And the third number pin is used for connecting the output. So if we want to take the output from the L293D, so we connect the any instrument that we connect to the L293D IC. So as in this experiment, we want to control the speed of the DC motor. So that's why we connect the motor first terminal to the output 1 and the motor second terminal to the output second, that is pin number 6 of this IC. Okay, and the fourth number pin and fifth number pin of this IC is connected to the ground. Okay, and the seven number pin as I already telling you, that is the input second of this IC is connected to the digital input output port of the Arduino. And eighth number pin of this IC is connected to the battery supply, means the battery is connected to the eighth number pin, means the positive terminal of the battery is connected to the VCC2, that is 8 number pin of the LM293D IC, and the negative terminal of the battery is connected to the ground. Okay, and similarly, if we want to enable the or active the right side of this IC, we connect the 16 number pin of this IC to the supply, 5-volt supply that we obtain from the Arduino. So that's why we connect the 16 number pin and to the 5-volt supply of the Arduino. Okay, and input 4 and input 3, that is on 15 number pin and 10 number pin. So we connect to the digital output port of the Arduino. Okay, from 0 to 13, you may choose any pin, it's your choice. Okay, so the output 4 and output 3, we can use these ports, that is 14 number pin and the 11 number pin of this IC. Okay, for taking the output from the AL293D IC. Okay, so likewise, if we want to connect two motors in our project, so we can connect one more motor into these ICs. Okay, and the 30 number pin and the 12 number pin of this IC we connect to the ground. Okay, and here the 9 number pin is enable 3, 4. Okay, so we connect the 9 number pin of this IC to the 5-volt supply. So by doing this, we can use this IC for in working condition. So now the question arises, why we use this IC? So we use this IC L293D in our project because if we want to the motor not working on the 5-volt supply. Okay, so it all work on the 9-volt supply or 12-volt supply. So the Arduino only give 5-volt supply. Okay, so that's why we use this IC, because by using this IC we get the 12-volt supply and operate the motor easily. So that's why we use this IC. Okay, so now we move on to the circuit diagram. Okay, so here from this circuit diagram, as I already telling you, that the input 1 we connect to the second number digital output port of the Arduino, and the 7 number pin is connected to the third digital input output port of the Arduino, right? And the third number pin, okay, third number pin and the 6th number pin of this IC. Here you see that output 1 and output 2 we connect to the motor terminals. So same thing. And as we want to control the speed of this motor by using potentiometer. So this is our potentiometer. So potentiometer is actually 3-terminal device. So the first terminal of this potentiometer is connected to the 5-volt supply, and the middle terminal, that is a wiper terminal, is connected to the analog input ANO, and the third terminal is connected to the ground. So by doing this circuit arrangement, we can use this potentiometer in our experiment for controlling the speed of this DC motor. Okay, so now we move on to the Tinkercad for designing our circuit, same circuit on the Tinkercad. So here you see that this is our Tinkercad. Okay, so as you see here, so in order to perform this experiment, we have a requirement of a breadboard. Okay, this is our breadboard. Taking drag and drop from the right side screen and place this on this side. Okay, and the next component for performing this experiment is our Arduino Uno. So this is our Arduino, and rotate this Arduino Uno by using this option. Okay, so this is our Arduino Uno, and now we now search for the L293D IC. So when we search in the search bar for L293D IC, so here you see that this is our L293D IC, that is our H-bridge motor driver. So by clicking drag and drop and rotate this IC and place this IC onto this side. Okay, and here we very well know that, and I already telling you. Okay, so first of all, we use this first pin IC. So first pin of this IC is can be enabled when we connect this to the 5-volt supply. Okay, so in order to give 5-volt supply, we use positive horizontally shorted slots, and for the ground connection, we use negative horizontally shorted slots. Okay, for on both the sides. So here, that's why, and the 60 number pin of this IC, we also connect to the 5-volt supply. Okay, and here the enable 1 enable one, that is the 9 number pin, is also connected to the 5 volt supply. By doing this, we can enable the left side portion of this IC and we can enable the right side portion of this IC. Okay. So as we very well know that the fourth number pin of this IC is ground. Okay. So we connect it to the negative or horizontally shorted slots of this breadboard. Okay. So first, second, third, fourth, fifth. So the fifth number pin of this IC is also connected to the ground. Okay. And on the same side, on the opposite side, we have pin number. This is our pin number 9, 10, 11, 12. So 12 number pin is also ground. So we connect it to the ground like this. And the 13 number pin is also ground. So we connect it to the ground, right? So now we connect the horizontally shorted slots, means negative horizontally shorted slots together, and positive horizontally shorted slots together like this, and giving the color to the wire red. Okay. Now we take a wire from the 5 volt supply of the Arduino and connect it to the horizontally shorted slots, positive horizontally shorted slots, and now taking a wire from the ground of the Arduino, okay, and connect it to the negative layer of horizontally shorted slots and giving the color to the wire black. Okay, is this thing okay? So now the input here, the second number pin is input. Okay, so the second number pin of this input is connected to the, we take a wire, okay, and connect the second number pin to the second number slot and give the color to this wire horizontally, means pink color. And the next is our input second. Okay, so the input second, that is the pin number 7, we connect it to the third number pin of the horizontally shorted slots, means our digital input output port of the Arduino, like this. Okay, and here we have remaining the 8th number pin, that is our VCC, okay, and output port. So in order to connect the output port, we search for the motor. So when we search for the motor, so we use a DC motor. Okay, so we choose a DC motor, rotate this motor, and connect the one terminal of this motor, connect the, means one terminal of this motor to the third number pin and giving the color. You can give any color, you can give suppose red color. Okay, and the second terminal, you can connect it to the another terminal, this one, okay. So you may use this, you may use the green color. Okay, and now we connect a battery. This is our battery, right? So rotate this battery. This is our battery now, and we can connect the positive terminal of this battery to the 8th number pin and giving the color to the wire red, and the black terminal of this battery we now connect to the negative horizontally shorted slots, giving the color to the wire black. Okay, and now we can here you see that this is our input 4 and this is our input 3. So you can connect this port to the digital input output port of the Arduino. It's your choice. Okay, it's your choice. You may connect this to the 4th number pin and giving the color pink. Okay, and here this is our input 3, and you can connect this to the 5th number like this. Okay, and here we have remaining 2 ports, that is for the output. Okay, this one means 16, 15, 14 number slot, and here we have 8, 9, 10 number slot. We have remaining these 2 slots for the output. So if you want to connect one more DC motor over here, so you can connect the DC motor on these 2 slots from the output 4 and output 3rd. Okay, so now we are going to write the program. Sorry, we have remaining potentiometer arrangement. This is our potentiometer. Okay, so we can rotate the potentiometer over here, and now so as in our as given in the circuit diagram that I already shown to you, this one. So in the potentiometer, the first terminal is connected to the 5 volt, middle terminal is connected to the analog input, and the second means the third terminal is connected to the ground. So we now make the same arrangement on our design circuit. Okay, so the first terminal is connected to the 5 volt supply. So we already knows that the 5 volt supply is available on the first pin of this first pin of the IC. Okay, so we connect it over here. Okay, so you can change the color of this wire to blue. Okay, and the second terminal, as I already telling you, the second terminal is that is the middle terminal. Middle terminal of the potentiometer is a wiper. So we connect it to the analog input ANO. Okay, so now you can give the color to the yellow. Okay, and the third terminal you can connect to the ground. Okay, so the ground terminal is already available on the Arduino, so you can use this. Okay, we can connect the third terminal to the ground. So by doing this type of connection, our circuit is now complete. Okay, so now according to this circuit designing, we now write the program. Okay, so now when we going to design the we now write the program according to this design circuit. So when I click on the code, so here you see that this is the programming for the designed circuit. So in the programming here you see that we write over here define M1, M2, M3 and M4. So M1, M2, M3 and M4, these are actually the digital input output ports where we use these digital output port of the Arduino for that is connected to the L293D IC. Okay, so here 2, 3, 4, 5. So 2, 3, 4, 5 is our digital output ports of the Arduino. 2, 3, 4, 5 as mentioned here. Okay, so we define integer over here, that is integer port is equal to A node. So port represent the potentiometer value, okay, that we connect to the analog input A node. and integer value. Integer value represents that when we change the potentiometer, so that what is the value by changing the value of the, when we move the potentiometer, then what is the value of the potentiometer it represents. So in the programming, we have two main type of the programming, that is void setup and void loop. So in the void setup, we define that which port we use for the input and which port we use for the output. So as in our experiment, we use the 2, 3, 4, 5 for the output. So that's why we write over here pin mode M1, M2, M3, M4. So it's your choice if you want, if you don't want to write, if you don't want to define these ports at the start of this programming. Okay, so you can mention that 2, 3, 4, 5 output over here. Okay, it's your choice. So although we connect, we use the second number port and third number port in our project. So okay, so you can write over here pin mode second output, pin mode third output. Okay, so if you want to use the two motors, so you can mention in our project that pin mode 4 and pin mode 5 we also use for the output. Okay, it's your choice. So now serial.begin 9600. So this command we use in our project. This command we use in our project for because we use the analog input. Okay, we use analog input in our project, so that's why we use this project. We use this command serial.begin. So in the serial.begin, why we use? So serial.begin is actually communication between the potentiometer and the Arduino. So the communication means whenever the value of the potentiometer changes, so Arduino receive it, and the 9600 is the communication speed between the potentiometer and the Arduino. And now the next is our program execution step, that is the void loop. So in the void loop, we have the first part is we define value is equal to analog read port. So here the value that is received by the Arduino, okay, through the potentiometer is our analog signal. So that's why we write over here analog read, and value is equal to map value 0, 1, 0, 2, 3 and 0, after that 255. Actually, when we move the potentiometer complete, so the complete value of the potentiometer changes from 1023 up to 1023. Okay, but we want to observe the value of this potentiometer up to 255, because our result we get accurately up to 255 value. So that's why we write over here 255. Means the value of this potentiometer varies from 0 to 255. Okay, and the next is our serial.println value. So that what is the meaning of this command? The meaning of this command is that if we want to display the value of this potentiometer on the screen line wise, okay, so we use this command serial.println into my value. Okay, and the next is our analog write M1 value and analog write M3 value. So by using this command, we can get the result. Okay, so now I start the program. So when I start the program, in order to check the value, so just click on the serial monitor. So here you see that when I click on the serial monitor, so you get the value 132, 132 like this. So this is actually the potentiometer value. Okay, so when I move this potentiometer to the clockwise side, so here you see that the value of the potentiometer is increases from 178, and you see that the speed of the motor is increases. Okay, so when we further increase the value of this potentiometer, so this is displayed on the serial monitor. Okay, and when I maximum rotate this potentiometer, so the maximum value we get 255 as I mentioned in this program. Okay, and the speed of the DC motor is now maximum. Okay, And now when I rotate this potentiometer in anti-clockwise direction, so when I rotate the potentiometer in anti-clockwise direction, so here you see that the value is now 0 and the speed of the DC motor is 0, means the speed of the DC motor is now stop rotating. So hence we control the speed of the DC motor when I rotate the potentiometer. Okay, so here this is all about the concept. If you want to save this program, so you may write over here DC motor speed control using potentiometer. Okay, so click outside and your project is now saved in on the Tinkercad. So I think you grab a lot of things in this class. So if you are satisfied, so do like, share and subscribe my channel. Thank you very much. And if you want to know about that, how you design the circuit on the hardware. So I already designed the same circuit on the hardware. So the link for this is given in the description box. You please check and do like, share and subscribe my channel. Thank you very much for listening me. Have a nice day.